Find the allowable bearing capacity in pounds per square feet. In this problem, a strip footing of given dimensions will fail by puncture failure rather than general shear failure. The safety factor is 3. The groundwater table is 6 feet beneath the footing base, and a few other parameters are given. Let's begin with the safety factor, which equals the ultimate bearing capacity divided by the allowable bearing capacity. Since the problem asks to find the allowable bearing capacity, it equates to 1/3 of the ultimate bearing capacity. The ultimate bearing capacity for an infinite strip footing consists of a cohesion term, a wedge weight term, and an overburden term. The 3 bearing capacity factors are functions of the friction angle, phi. However, since the problem specifies a punching type failure mode, the values of phi and cohesion need to be modified, as shown. The given friction angle and cohesion for general shear failure are plugged into the equations, and the modified friction angle and modified cohesion for punching failure equals 8.06 degrees and 267 pounds per square feet, respectively. With the appropriate friction angle, we can now solve for the bearing capacity factors. Solving for the overburden multiplier, 8.06 degrees is plugged into the equation, and we get N sub q equals 2.07. Next, N sub q and phi are plugged into the other 2 equations, and we calculate N sub c equals 7.56 and N sub gamma equals 0.87. Having solved for the bearing capacity factors, the effective unit weight and overburden stress are left. In bearing capacity problems, the effective unit weight in the second term of the bearing capacity equation represents the effective unit weight of the foundation soil in a zone below the footing base, equal to the footing width. So for this problem, the footing width is 8 feet, which means B equals 8 feet. B1 and B2 are used to separate distinct zones of soil which differ in their effective unit weights within this 8-foot zone. With the groundwater table at 6 feet beneath the footing base, we set B1 equal to 6 feet and B2 equal to 2 feet. The effective unit weight for B1 is simply the total unit weight, and the effective unit weight for B2 is the total unit weight minus the pore water pressure. After substituting in the correct values, the effective unit weights are 120 pounds per cubic feet for B1 and 57.6 pounds per cubic feet for B2. Plugging in both effective unit weights B1 and B2, and plugging in all 3 B values, the effective unit weight to be used in the bearing capacity equation equals 104.4 pounds per cubic feet. The last unknown variable to solve for is the overburden stress, Q. The overburden stress equals the effective unit weight times the height of the overbearing soil layer. This unit weight refers to the soil above the footing base, which in this case is above the groundwater table and equivalent to the effective unit weight of B1, 120 pounds per cubic foot. With the height equal to 4 feet, the overburden stress equals 480 pounds per square feet. We can now solve for the ultimate bearing capacity of the soil. Substituting in the appropriate values, we find the ultimate bearing capacity for a puncture type failure is equal to 3,376 pounds per square feet. Since the safety factor in this problem is 3, the allowable bearing capacity is equal to 1/3 the ultimate bearing capacity. The allowable bearing capacity equals 1,125 pounds per square feet. Looking over the possible solutions, the answer is A.